This video is brought to you by Azam Sharp School, which is one of the biggest producers of iOS development videos. I mean, just check out this 16 courses, more than 90 hours of videos, more than 90 hours of content, and it just keeps on increasing. So by the time you're watching these, it might be like 20 courses with 120 hours. All right. And now on Azam Sharp School, I do offer the annual membership, which is $249, and monthly membership, $25 a month. And what's great about these membership options is that once you sign up for these membership, you can access to all 16 courses. And check out these amazing courses: test-driven development in iOS, reactive programming combined, Swift Vapor, server-driven UI, Reality Kit, Swift Data Bootcamp. I mean, it just contains all the things that you need to become an amazing iOS developer, and I keep on adding more courses. So there are more courses that will be added later on. So this is an amazing deal. You can check out the testimonials from our existing students, and this is again one of the largest catalog for iOS development courses. So sign up for either a monthly membership or annual membership and enjoy all of these courses. Thank you so much. Let's go ahead and get back to the video. Hello and welcome to a module on actors. Actors is a new feature in Swift language that allows you to protect the mutable state. You will learn how to access actor isolated states. What does isolation in actors look like? You will also learn about the main actor and how main actor can allow you to run certain properties, closures, classes, functions to be called on the main thread. And finally, you're going to look at non-isolated instances, meaning code that has nothing to do with actor and that does not have to be isolated. So let's go ahead and get started. In this lecture, we're going to learn about actors and how actors protect our mutable state. Before we dive into actors, let's go ahead and take a look at a very simple example. As you can see that we have created a class called counter, and counter consists of a single function, increment. When you call increment, it simply increments the property to +1 and also returns the updated value. If I go ahead and call the counter function, so I'm going to go ahead and create counter, and now I can go ahead and call the increment function by calling it counter.increment. It is going to print out 1. If I go ahead and do it again, it's hopefully going to print out 2. Let's go ahead and run this. I'm going to say increment, and I see 1 and 2. Looks like it's working. What happens if we are trying to call the increment function concurrently, meaning at the same time? I'm going to go ahead and use a dispatch queue .concurrent perform, and I'm going to call it 100 times this particular closure. Inside the closure, I'm simply going to put counter.increment. So we are basically trying to create or call counter.increment function concurrently 100 times. So what I'm expecting to see is 1, 2, 3, 4, 5, 6 in sequence till 100. If I go ahead and run the application right now and press on the increment button, I see a weird kind of a result. It's all over the place. It started with 2, 17, 18, and it just goes completely out of sequence. What is going on? Well, you started or you perform the concurrent task, meaning you called counter.increment concurrently 100 times. So we don't really know which one is going to get executed first. You're calling it 100 times, and any one of those can get executed first. So you can see that counter was 2 and then 17, so 18, 19, and so on. So the sequence is completely messed up. And the reason is that this is a shared mutable state. So whatever the counter incrementing you're doing, the other thread that is performing the same action will get the updated value and it will increment that part. But we don't really know out of these 100 iteration and concurrent tasks, which one is going to get returned first. Now, this is a problem with the shared mutable state. So you might be thinking, well, how about we don't share it? How about we simply go ahead and convert it to a value type where the things are copied instead of being shared? If we change it to value type, we have to make sure that our increment function is marked with mutating because we are changing the value. Next, we will go over here and try to perform increment function. The increment function is actually changing for the counter. So we need to make sure that this counter is not let or var. So we need to change it to a var. If you try to call this again with simply changing it to struct, nothing really is going to change. It's just going to give you the same exact result because it still have concurrency issues. We haven't really copied the counter, so everyone is using the same exact copy. Well, that's not a big deal because we can go ahead and create a copy. So I can simply go ahead and assign the counter to the counter. Since this counter is simply being assigned and not being incremented, maybe we can go ahead and change it to let now. So keep in mind that we are running concurrent operation, concurrent task 100 times. Every single time it is going to make a copy of the counter and then call the increment function on that copy. So what do you expect it would print out? It's all ones, because now the counter is not really getting maintained. You get a fresh copy. The fresh copy always starts with a 0, and then you call increment, which increment from 0 to 1. So even though we were able to change it and avoid the issues for concurrency, it didn't really produce the same output we were looking for. Now let's go ahead and see that how we can fix this problem using actors. The first thing we're going to do is change our struct or a class to an actor. Great. We don't really need the mutating part. This means that only one thread can update or call the counter at a given time. If you scroll down over here, we need to change this also. We will go ahead and call counter.increment. You can see that already we haven't even decorated the increment function with async, but since it's the part of the function inside the actor, it is already marked with async. If it is an async function, this means that we have to await for it. Awaiting basically means that once you call this function will be suspended. And then when it resumes, that will be in the future time, and then the other thread can jump in and then it can work. So at a given time, there will be a lot of different increment functions that will be suspended. Since this is the await keyword, we need to use it inside the actual task so that we can use await. So I'm going to wrap it with task closure, and then we can use the await. Now if I go ahead and run our example and press on the increment, you can see that everything is nice and in sequence. And the reason is that one person and only one person, one thread, can jump into increment and actually increment the value. Once that is finished, it is resumed from suspension, then the other thread can jump in and change the value. So that is why it is incremented in a correct way. So you can see that using actors, we were able to solve this problem. So overall, the whole point of using actors is to have a concurrent operation and no race conditions. Your function increment can be called from outside, which is changing a value of the actor counter, but in order to call that, you are awaiting for it so that no 2 threads or 3 threads can jump into the increment function and update them. They will have to wait their turn, and only when the one function is removed from the suspension or resumed, then the other person can jump in, other thread can jump in and increment it. So that's the whole point of using actors in Swift language. All right, everyone, let's go ahead and take our last example of the bank account. And you can see that we are not using the playgrounds anymore because at the current version of Xcode 13, the playgrounds with actors is not really working. So that's why I've created a Swift UI application to demo that how we can use actors to improve this application. Right now, this particular application is not using actors. Let's go ahead and go through this application. We have a content view. We're using the MVVM design pattern. So we create a bank account with $500 balance. We use a concurrent queue that we have used before to perform two different concurrent transactions to withdraw $200 and $500, keeping in mind that our initial balance was $500 only. We're also listing all the transactions that is going on. In our view model, we take help from the bank account, we perform the withdraw, and we update our published properties, which are current balance and transactions. Both are marked with published. That means whenever you will assign a new value to these two properties, it will be reflected. It will throw an event that can be intercepted by our view, and the view can display the updated value of these properties. The bank account class, it remains the same. You can see that we added a get balance function, which returns the balance. We have a withdraw function, and other stuff is just the same. If I go ahead and run the application right now, I can see the withdraw button. Let's go ahead and click on withdraw. And you can see that when we withdraw, then our balance ends up being minus 200, which is not good. This is not what we want. So how can we use actors over here to solve this problem? We'll go back to the account class. We know that if we put actor, simply the word actor, then this means that anything that you're trying to do with the bank account class, it has to be isolated. So you can't really access it from outside of the bank account without awaiting for it. So you can already see some problems. The bank account view model, which was calling the actual bank account class function withdraw, is having some issues. And we get an error saying actor isolated instance method withdraw cannot be referenced from a non-isolated context, which basically means that now something outside of the bank account class, which is, this is a bank account class, is trying to call bank account and trying to actually change the bank account because we are changing the balance property. But somebody from outside of the bank account is trying to call the functions of the bank account. And if that is going to happen, then it can create race conditions and it can end up with unstable state. So what we need to do is we need to find out that how we can do it in such a manner that two particular threads are not writing the information or performing a write operation at the same time. Let's go ahead and await for it. If we await for it, this means that now we have suspended the withdraw operation, and unless that operation finishes, no other thread can jump into and call withdraw again, unless it is finished. Now I can't really await on something that is not async, so I will go ahead and add an async keyword so that I can await for it. By adding the await on the call for the bank account of withdraw, we have suspended this particular thread, and unless and until this particular thread does its work and withdraw, no one else can jump in, as I mentioned before. The same is true for get balance, and the same is true for transactions. We need to make sure that we are awaiting for it. So let's go ahead and call await. and await. We will also go ahead and remove the dispatch queue part. There we go. Let's go ahead and build it. If we try to build it, we again see some issues. Now, those issues are mostly related with the dispatch queue. Since we are awaiting, the call has to be awaited, which this means that the dispatch queue is not really going to work because that's not the syntax for performing async and await. So if we do want to perform async and await, we can use task.detached. This is going to perform two different tasks concurrently, namely the first task, which is withdrawing $200, and the second task, which is trying to withdraw $500. Again, since the withdraw function in the view model itself is async, we need to await for it. So let's go ahead and add await. Let's go ahead and build it. Great. Now with these changes, let's go ahead and run our application and perform those multiple withdraws concurrently. If we perform the withdraw, you can see that since we were calling $200, that's the first withdraw, so 500 minus 200 is 300, and we ended up with 300 as the balance. So it didn't really go into minus 200 or some sort of a negative balance. It knew that after I have performed the $200 transaction, the $500 has to wait because the thread has been suspended at that point for its turn. And when the turn comes for the $500 transaction, well, 500 is more than the bank account balance, which was at that time was 300, so that transaction never really happens. Now, if I go ahead and change this to 500, and if I change this to 200, then you might see a different result. The ordering doesn't really matter because the detached part is going to do the detachment or performing these operations in concurrent manner. But in this particular cases, and if I even run several times, it looks like the first one is going through. But that's not really 100% the case or all the time. If you run it in a loop, there is no guarantee who is going to go in first. Is it going to be 500 or 200? All right. So anyone can go, anyone can get executed at any point in those cases because they are trying to execute concurrently. So you can see that by using actor, we have solved the problem. We didn't really have to use serial queues. We didn't really have to use any locking mechanism, but we simply added an actor which solves the issue of concurrency and the race conditions. Make sure that when you are using actors, you are awaiting for these things. Because if you're not awaiting, then first of all, it's not even going to compile. It will give you an error. And if you're not awaiting, then that particular thread is not really suspended. And if it's not suspended, then anyone else can just jump in and change the stuff. And we're back to equation number 1, where two threads are trying to change something at the same time. So actors has allowed us to isolate those things, and we can now build our application with much more confidence that actors are going to be there to help us out when we are trying to access one thing and one thing at a time. Now, one final thing that you can add to your view model is you can add a main actor over here. Now, the main actor basically means that anytime you're going to set the property or anytime you're going to call a function, that will be done on the main thread. So if I go ahead and run the application again and try to withdraw something, you can see that right now, since we're withdrawing $500, it gives us $0. That's fine. If you don't use the main actor, then there is a possibility that if you try to set the current balance and transaction, which are both marked with publish, then we will not 100% know that which thread were they set up on, meaning when they were assigned. So main actor is going to make sure that your properties and your functions are actually called on the main thread. So that is a very good property wrapper that is available to you in iOS 15. All right, so now let's go ahead and look at another example of actors in Swift. You can see that we have created a class called bank account. It has two properties, account number and balance. We have a function called transfer, where you have to pass in the amount that you want to transfer and to another bank account. So that's the instance of a bank account class that you must transfer. We check if the amount is greater than the balance. If it is, then we throw the insufficient funds because we don't really have that much balance. If everything is good, we subtract the amount from the balance and we deposit the amount to the other bank account and we simply print it out. What will happen if you try to run this concurrently? That's exactly what we're trying to do. As you can see on line number 46, we're trying to run this 100 times. We're trying to transfer $300 from the bank account, which has $500, to the destination bank account, which has $100. Let's go ahead and run this. All right, so I'm going to go ahead and run this and press on the transfer button. So this looks fine. If you are transferring $300, the current account has $200 because 500 minus 300 is 200, and the other account already had $100, so 100 plus 300 is 400. So that's correct. But if you try to run this number of times, or if you try to invoke it number of times, you can see that it's all over the place. And the reason is that you are trying to run concurrently, and we don't know which task is or which thread is going to get access first to the transfer function and which one is going to get returned. So that's why you can see that sometimes it produces the correct result, but sometimes it can produce some weird result. So now the question becomes, well, okay, how can we use actors to solve this problem? If we're using actors, the first thing we need to do is to change our class from class to actor. If we change it to actor, we immediately have some issues. You can see that on line number 30, it is saying the actor isolated property balance cannot be mutated on the non-isolated actor instance. So basically what we're doing is that since the other is of type bank account, we are trying to change one of the properties of the other instance, which is a bank account, and this is not allowed. The only person who can actually change this is the bank account itself. So what we need to do is we need to create a separate function, deposit, in which you can deposit the amount. And since this particular function is available on all the instances, objects of type bank account, we can replace this line with the deposit function. So on the actual object, we can call deposit. Over here, I'm simply going to say balance plus equals to amount. That is fine. And instead of doing this over here, instead of changing one of the properties of an object, because if we change it, if we're allowed to change it, guess what? We're back again with the race condition. Who's going to change it first? And then everything gets messed up. So what we need to do is we need to allow the actual object to change that number. Unfortunately, even by calling deposit on the other object or the other bank account, it is still going to give you this particular error. And the reason is that we haven't really solved concurrency, because anyone can simply call deposit now and change it. So again, it's still a race condition. What we really want to do is we want to await on it, meaning only one single thread can go and jump into the deposit function and increment the amount. Now we're trying to call await on a transfer function which is not really marked with async. So let's go ahead and mark this with async. Let's go ahead and build it. Okay, so that at least that problem went away. We may have some other problems. Now in this case, you might be wondering that we marked async, the transfer function, but why didn't we mark deposit with async? The deposit function, since we are calling the deposit function on the instance itself, is already marked with async since it is part of the actor. So if I say other.deposit, you can see that it is already marked with async. The same is also true that if I call other.transfer, you can see the transfer is also marked with async. Okay, so now we got that working. Let's go ahead and build it. Now we have a problem over here. It's saying that there's something wrong with other.balance. So whenever we're trying to print the balance, there is a problem. Well, that's kind of weird because if I go ahead and say other.account number, is it going to complain the same way? Well, it doesn't. So if I'm printing out the account number, it doesn't really complain. But if I try to print out the balance, then it starts complaining. Why is that? Well, one of the things you will note about the account number is that account number is actually marked with let, which makes it immutable. You cannot change it. So if you cannot change it, it will never have any concurrency, race conditions, or any issues. But other.balance, or simply the balance property, is marked with var. This means it can be changed outside of the actual object or actual class. So in other words, we have to make sure that we are again awaiting for this. So only one thread and one thread only can access the actual balance. Now let's go ahead and scroll down. We have now issues on the calling part of it. We are calling the transfer function. Transfer function is marked with async, so we will have to do an await. We can't really do an await because we are not really inside the context of async, so we can use the task features. And now we are in that particular context. Great. Let's go ahead and run our application and try to perform the transfer again. Now, no matter how many times I click, it always prints out the correct result because only one transaction or transfer is taking place. So this is making sure that we have solved this race condition and concurrency issues that we were facing when we were using classes. Now, since the transfer function is called, we will wait for the deposit to happen. So this is with a suspension point, and no thread can simply jump in and start changing things unless and until that particular task is completed. The same is true for when we are trying to access the balance property. Because the balance property is marked with var and it can be changed outside of the class itself, that's why we have to await so that only one thread can access it at one time. So this is another example that we learned how to use the new actor features in Swift language. In the last lecture, you learned about actors, and you also learned that whenever you're trying to call a function which is contained inside the actors, you need to make sure that that function is called asynchronously using async and await. But what about functions that are not really changing the state of the bank account? What if I have a function called getCurrentAPR? Now this function is not really changing anything. It's simply going to return a constant value. If I go ahead and try to call getCurrentAPR, and since this function getCurrentAPR is inside bank account, I have to make sure that I'm calling it asynchronously using async and await. This is going to make sure that we're not changing anything, and this is also going to make sure that no other thread can jump into and change something. But we're not really changing anything in this function. We're simply returning some sort of a constant value like 0.2. So if I go over here in my button and write the code for bankaccount.getCurrentAPR, you can already see that it is decorated with async. If I simply going to call this function, getCurrentAPR, and try to compile it, it's not really allowing me to compile this because it's asking that you should await for it. And I can't really await because I'm not in the context of an async. So I have to create a task in order to call getAPR. But the difference between the getCurrentAPR is it's not like other functions. It's not like a deposit function or a transfer function, which is actually making changes to the properties. So in other words, this function doesn't need to be isolated. You can call it, and we know that this is not really going to change the state of the bank account. It's simply going to return some constant value. So if you are 100% sure that this particular function is going to be able to run in a non-isolated scenario, and it's not going to mess around with the threads, it's not going to cause any race condition, then you can simply go ahead and decorate that with non-isolated. Non-isolated simply means that this function can be called and it's not really going to cause any race condition, and you don't really have to use async and await or asynchronous call to call this function because this particular function is not changing anything. Now if we go back, you can see that this particular function is returning us something. And we don't really have to call this function using the async await feature. Now what if we are trying to change something inside the getCurrentAPR? So if we go back to the function and try to change the balance, it is going to complain because this particular function is marked with non-isolated. So this means that it was not really allowed to change these values in the context that we are currently in. We cannot really mutate anything. We cannot really change anything. This is a non-isolated context. So we can't really do that. Another thing is if you go ahead and change the account number. Well, account number is already marked with let, so you can't really change that. And it doesn't have to be inside non-isolated because it's a let, so you can't really do anything with it. So in scenarios where you know that the function can be run in non-isolation, doesn't need to be isolated, you can decorate it with a non-isolated keyword, which means that you can call it without using the async and await syntax. It will simply call the function. It's not really going to change anything or aspects of the actor itself because right now it's just returning it. So that's the whole point of using a non-isolated methods in Swift language. Welcome back, everyone. Let's go ahead and get started and learn about the main actor in Swift language. Now, here's a simple application. You can see that I have created a service which goes to a JSON placeholder URL and it retrieves all the to-do items. I have created a to-do model class which consists of the ID, title, and completed properties. And I also have a to-do list view model that uses the web service, get all the tasks, and finally sets the to-dos property, which is declared on line number 12 with all the different to-dos item. Make sure that you understand that the to-dos property on line number 12 is marked with published attribute. What will happen if I try to run the application right now? So if I run the application, it works perfectly fine. It displays all the different to-do items, but you can see behind the scene, it is telling me that there's something wrong. Publishing the changes from the background thread because the web service is using callbacks and then the callback happens on the background thread. And we're trying to change the to-dos property, which is marked with publish, on the background thread. So that is not really allowed. You shouldn't be doing that because it can create some weird kind of results and sometimes even it can break the app. So what can we do to solve this problem? Well, in our case, we can simply go ahead and write dispatch.main.async, which is basically meaning that we are switching to the main queue, the UI queue or the thread. And now we will set the to-dos property, which is marked with published property wrapper, and we will change it, assign it on the main thread. You can see that now the error or the warning is now gone. Great. In iOS 15, we have now introduced a new way of setting these properties. One thing to keep in mind is that the main actor that is introduced in iOS 15 works the best if you are using structured concurrency using async and await features, which was introduced in the new version of Swift language. So right now you can see that we are not using async and await. We're simply using the plain old callbacks. So in this particular model, although it can work, it's not really going to be that beneficial. But let's go ahead and see how it will work. If I go ahead and mark main actor on my to-do list view model, then it's basically saying that anytime we are going to use or set publish property or any of the property in any of the function, we're going to call on the to-do list view model, it should automatically set on the main thread. If I go ahead and try to run this application just by marking the main actor, we can see that it doesn't really work. It's giving us the same exact issue, even though we have marked over here that this is the main actor. So this is what I'm talking about, that the main actor and the property wrapper and everything related to the main actor will work really great if you are not using the callbacks, but you're using the structured concurrency using async and await. In async and await model, and if our function getAllToDos was using async and await, then everything would have worked as expected. But it's not. It's using the classic old callbacks. So our option with callbacks are a little bit different. We can go ahead and use the dispatch queue.main.async. That is fine. Or we have to make sure that we are setting this particular to-dos property on the actual main thread. So how can we do that? Well, one of the ways you can do that is to call the main actor.run closure. In main actor.run, you can simply set this particular property. Main actor.run requires an async, so we will have to make sure that we are calling it with await. We cannot really wait on anything when we are not inside the async context, so now we have to wrap it again with the task. If I go ahead and build this and try to run it again, then you will see that it's not really going to give us any of those warnings that we saw before, because now the to-dos is assigned on the main thread. But you can see that we had to write extra lines to get that to happen. It will be much easier if we just use dispatch queue.main.async in this case. Another way of setting everything on the main thread is by using the actual closure itself, which is being returned from the web service. With escaping, we can go ahead and mark with main actor. Now, if I go ahead and build the application, I will get this following error. Basically, it is saying that now the completion is marked with main actor, so you need to call this in isolation. So if it's a main actor, that means we can await for it. But we can't really await for anything because we are not inside a task. So let's go ahead and put it inside a task. And we have to do this for every single piece. So we will put an await for it. So you can see that our work is much more than it was earlier. And the only reason that we had to do all of this different work is that we are not really using structured concurrency in Swift language. We're just trying to cover up for our callback functions. After this, you can see that everything is now going to be firing on the main actor or on the main thread. Now I can go back and I can simply run the application without writing anything associated over here, and it will always work correctly because everything is fired. The closure, the completion closure, is actually fired on the main thread. So we don't really have to do anything. This is not really a very good solution because we had to type a lot of code for this to happen. This is just to show that if you want that approach, you can pass the main actor as a property wrapper on the closure itself. But I don't think that's a very good solution. So I'm just going to remove that part. This means that we have to remove all of these different things, the await and the task, everywhere that we have used. So this was just to show you that it can be done, not that you should do it. All right. The main actor can also be decorated on the actual functions. This means that the populate to-dos function is going to be fired on the main actor. Again, this feature is only going to work if we are using the complete concurrency model of the Swift language. So right now, the populate to-dos is not really going to be doing anything on the main function. I mean, it will be called on the main thread, but once you go inside the closure of web service, then again, we're back to the background thread. So just by marking this with main actor doesn't mean that your to-dos property, which is marked with publish, is going to be set on the main thread, as you can see the problem. Now, one of the great ways that you can solve this problem, and we have already seen, we can use dispatch queue.main, we can use a main actor.run, we can use the completion block that we saw over here by marking with main actor. But if you want to go for future, then I would just try to change get all to-dos into an async function. So let's go ahead and create an async function for get all to-dos. So I'm going to begin right over here. And just to name it a little bit differently, I will call it get all to-dos async. Please make sure that if you are writing this in your actual application, I would not add async keyword. This is just to show that this is not colliding with the original name that we had. Since this is an async function, I'm not really going to be passing in any callbacks. I will be, however, saying async throws because it can throw something. It will eventually return me an array of to-do objects. Great. So let's go ahead and get started. The first thing we need to do is we need to make sure that we have the URL, which we do because that is being passed. That's great. Next up, we can go ahead and say URL session.shared.data. And in the data, we can pass in the actual URL. So there we go. The URL session.shared is a async function. This means we can await for it. So let's go ahead and put await. And it can also blow up. So we're going to use try. We will get something back, which will be data and a response back. Much nicer. And now we can go ahead and decode the response. So JSON decoder.decode, and we are decoding a to-do list. So to-do.self, an array. We will pass in the data. This is going to return us a list of to-dos, I believe. And now in the end, we can go ahead and return to-dos. The try over here or the JSON decoder, this can also blow up. So we will make sure that it's not really blowing up. And if there's a problem, we can either return to-dos or an empty array. So this is our function. All right. Now let's go ahead and call this function. So this is called the get all to-dos async. So I'm going to go back over here. I'm going to remove the main actor and everything. The URL, I believe, is fine. That is perfectly okay. The web service call is going to be a little bit different. So web service dot get all to-dos async, passing in the URL, and it is going to return us to-dos. We will have to await for the function to get it returned. We can't really await for the function because our function populate all to-dos is not marked with async. So let's go ahead and mark this with async. Also, our function get all to-dos async can throw an exception. So we need to make sure that we are calling it with try. Hopefully it will return us all the to-dos. And once it does return us all the to-dos, we can perform a map function on it. and we can try to convert it to to-do view model.init. This is going to give us all the different to-dos. Perfect. So this to-dos that we have assigned is the one that we have created right over here, which is also marked with published. Keep that in mind. Let's go ahead and run the application. And we'll see that if it is allowing us to display everything or not. Okay, so currently we are getting an error. And this is the error that we are getting. Let's remove this part. So on the on up here, we're trying to call populate all to-dos, but in order to call populate all to-dos, since now it's an async function, we have to await for it. We don't have to use on up here. We can now start using task, which is already marked with async closure. If I go ahead and type it again, you can actually see task right over here. You can see that it is already marked with async. So it's an async closure. This means I can await inside this particular closure. And if I'm awaiting, I would probably use the await keyword also. Now let's go ahead and run this. Okay, so it's running fine. Let's go over here. There we go. So everything appears to be working just fine. We didn't even use main actor. If we go ahead and run our application, you saw that it is running perfectly fine. It didn't really give us any error, and it didn't say that you were setting the to-dos property on the different background thread. And the reason is because we are inside the async function and we are awaiting for this particular result. And the await happens on the main, on the UI thread. So once the thread is resumed, we're back to the main thread on which we set the property, which is to-dos. Great. But what happens if we didn't really make the call on the main thread? What happens then? So let's take a look at that scenario. What about if I go ahead and say task.detached and try to perform that inside task.detached? Now, this basically means that it's definitely not going to be on the main thread. It's going to be some other thread. And you can also check that if you print out the property, if you just simply say thread.isMainThread, it is going to print out false because this is not the main thread. Let's go ahead and comment out these two things so we can just see that if we are inside the task.detach, what it is printing out. And you can see right there, it is printing out false. So this means that it is not on the main thread when we are inside task.detach closure. What about if we try to run the code now and keep everything the same? So we are making this call on some other background thread, and we are trying to set this on probably the background thread or some other thread. Now, back again, we are faced with the same exact issue. Publishing changes from the background thread is not allowed, right? Now, what happens if we go to the to-do list view model and if we are using the latest feature of main actor? And that is the difference that we are trying to see. Since I have decorated this with the main actor, it is telling us right on the spot that, hey, this is really not allowed. What you're trying to do is not allowed. You're trying to set something which is marked with main actor, and you're trying to set it inside a background thread. And the reason it is complaining is also because we have marked the property wrapper or decorated the property wrapper on the to-do list view model. This means that every single property and every single function inside the to-do list view model must be called on the main thread. And that's exactly what we are not doing. We're not really calling it on the main thread. Now, this code is obviously something that you will not write because we are trying to move it to the background thread and trying to make the call. But if that ever happens, and if you see ever this kind of an error, this is basically suggesting that you're trying to call something, but that something is not on the main thread. So you have to jump on to the main thread. So how do we jump on the main thread? Well, we can use the main actor dot run, and we can make sure that this is run on the main thread. All right. Now we have done that. Let's go ahead and run this application. You can see that you're no longer getting that error because we have switched the thread, and now we are making sure that the closure is performing on the main thread. In your actual application, I don't really think that you will be using tasked or detached. This is just to show you that if you were performing a call on the background thread or not on the main thread, then the context that is set for that particular function for the async is not the main thread, it's the background thread. If you go inside the closure, which is main actor.run, and try to print out that if this is on the main thread, then you will eventually get that yes, it is the main thread that we're running on. And that is why it never really complains. So the main actor property wrapper allows you to make sure that the properties, the function, or both of them are actually running on the main thread. Just by decorating it with the property wrapper doesn't really make sure that they are running on the main thread. That's still your responsibility. But if you are trying to do some weird stuff like the one that we're doing, trying to execute code inside task.detach, which is a background thread, then instead of a runtime error, it's going to be a compile time error where your compiler is going to tell you that, hey, what are you doing? You have marked this with main actor and you're trying to set a property. Please make sure that the property is set on the main thread and not on the background thread. So it becomes your responsibility. All right. So that's the whole point of the main actor. It is going to be watching you. The compiler will be looking at your code, and it will, if it sees that you're trying to set some property, whether it is the to-dos or whether you're calling populate to-dos in a background thread, then it will complain. So there you have it. This is the new feature of Swift language, main actors in Swift.